Hello, 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 hello. Mic test, 1, 2, 3. Hello. Okay, I think I am audible. I am audible now. Okay, fine. So, hello everyone. Today is my day 9 of C++ DSA journey. In today's stream, we will be revisiting some old array-based lead code problems. After that, I will try to do a new question based new problem after that. Okay. So mic checking has been done. The mic is working fine. So today my today my new mic has come. This is the that is from Boya company, and it is a very good mic for beginners who can beginners can use this mic. So this is my first stream with this mic. Okay, so let's start the stream. So first we will what we'll be doing. We will revisit this problem that is majority element second again that we solved yesterday. But I think before solving this, I think I should solve this problem. I think I should solve this problem first that we solved yesterday using Moore's algorithm, which was the most optimized approach for this. Because I haven't revisited the problem yet, this problem yet. Like on 19th of June, I did this problem with the brute force approach. After that, I used the better approach for it. After that, yesterday I did this problem with Moore's algorithm, which is the most optimized algorithm for this approach for this problem. So now today I will try to resubmit the solution again and understand the problem in more detail and will explain these things to all of you also. Let me check if mic is working. Okay, hello, hello, hello. Okay, so mic is fine. So what we will do, we will first take a glance of the code. Okay, this is the glance. We declare the frequency is 0, answer is 0. Okay, if this is this and that. Okay, 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 okay. So we will directly jump onto the problem. I think today the stream will be a little bit low energized because today I was stuck in some matters. So, but we will do the stream. So first of all, what we was okay in this problem we have to find majority element. Okay, there will be given an array. Inside this, we will have to find the element that appears more than n by 2 times. So we will use Moore's algorithm again for this. Moore's algorithm says the if an element is in majority in an it will its frequency will be higher even after cancelling it with other elements. So let me take a glance of it again because my mind is not my mind is working a little today. So okay, yeah. We don't even have to use sorting in this problem. Okay, like we only have to count the frequency. We only have to count how much stronger is the frequency of an element, and we'll print it at the end. We will print the majority of that element in the end. That frequency will be the highest. So it will be the majority element in that case. Okay. What we will do, we will start. We will initialize the frequency with 0 and answer is equal to 1. Sorry, answer will be also be equal to 0. Yeah. So that what we were supposed to do, we were supposed to create a for loop. Inside that, we will traverse through the whole array. We will traverse through the whole array. Inside this, we will check. We will do a check if frequency is equal to 0. Then what we will have to do? We will have to initialize answer is equal to nums, the current index of nums. Okay. Yeah, this same here. After that, we will create another condition which will check if answer is equal to nums of I. What we will do? We will increase the frequency. After that, we will check if this is not true. In the else case, we will reduce the frequency. Okay. So after that, we will return the answer at the last. After this for loop, if we run it, okay, it is accepted in the first run. So now I will tell you how the code is working. So what we will do, okay, this is done. Let me check that thing that that the contest that we participated in the yesterday's stream, day 8 stream, is it reflecting on my count or not? So it is not reflecting. Here you can see, I have seen in my profile that it shows in a container like structure. Inside that shows how many contests I have attended and how is my rating overall. It's not showing here, but it is showing inside the contest, inside the section of contest where it is gone. Okay, it is outside. This is my contest that I have participated. Okay, I haven't. How I got ranked when I have not participated in this? See what has happened in this. Okay, it gave me rank only because I have registered. Okay, but not participated in this. So this was the history of it. We we did this and okay. So this is that. I think it will reflect after when I will have been participated in I think more than 10 contests. Okay. So now the solution has worked, and now I will explain you the I will dry run the problem. I have already dry run it before, see, in date with Moore's algorithm. So in that case, let me use the highlighter here. Okay, pointer. See, for example, we take an array like this, and we know the majority element will be one in this. Because we can see one has occurred more than n by 2 times. Okay. So how the Moore's algorithm works? When frequency will be at the start is 0. Okay. When let me put the code here and the stream button here. Okay. So when frequency is 0, at the first iteration, I will be also at the 0th index. In this case, that is 1 in this case. So inside this, it will check if frequency is equal to 0. Then answer will be the current index of I, that is 1. So in answer, it will become 1 in answer. Okay, it will become 1 in answer. After that, it will check if answer is equal to nums of I, and in this case answer is equal to nums of I. Okay, so frequency will be increased. After that, what will happen? It will come in the next iteration. I will be equal to 1, that is 2 in this case, and it will check again if frequency is equal to 0. But in this case, frequency is not equal to 0. Then this condition will not be executed. After that, it will check if answer is equal to nums of I. So in this case, answer is not equal to nums of I, because there is 1 stored in the answer and frequency and nums of I value is different. So what will happen in this case? In this case, frequency will decrease. Okay, so in this case, frequency will decrease and it will again become 0. But the value stored in answer is not changed yet. Okay. So what will happen in the next iteration? In the next iteration, I's index will be at index number 2. Okay. So it will again check if frequency is equal to 0. So if its frequency will be equal to 0, then we will reinitialize the answer value with 2. In this case, because frequency has become 0, so answer will be changed and we will reinitialize the answer and 2 will come inside that. So after that, it will check if answer is equal to nums of I. So in this case, answer will be equal to nums of I, but answer will be equal to nums of I and the frequency of it will increase from 0 to 1 in this case. Okay. After that, when in the next iteration, I will be on the 3rd index, and what will happen here? So this condition will not be executed because frequency is 1. After that, you will check if answer is equal to nums of index value of nums I. Okay, but in this case, the answer is not equal to index value of nums current index value of nums I. So what will happen? The frequency will be reduced to 0 in this case, and 2 will not be erased. 2 will not be erased in the answer. It will be in the answer, but in the next iteration, when I will be on this last index in the traversing of the array, what will happen? It will check if frequency is equal to 0. So in this case, frequency will be equal to 0, and it will reinitialize the answer with the value 1. And what will happen if answer is equal to nums of I? It will increase the frequency, and in the end, the frequency will be 1. And what will happen after that? We will return the answer in that case. So the answer will be equal to 1 after cancelling it with all the other values. So 1 will be the major element in this. You can see the test cases are also giving the right output. Even here you can see 2 is the majority element. If we add our own test case here, let's create our own test case here. It will be 1 1 1, 2, comma 2, comma 2, comma 2, comma 1, comma 2. Okay, in this case, the result will be equal to 2. See, the result will be equal to 2. So this is how Moore's algorithm works. It says even after cancelling the frequency of the number with other elements, if frequency will be that higher, that in the end it will be left remained. So this is how Moore algorithm works, and it gives the majority element. Now what we will do, we have submitted the code today, so I will go back to my account. Let's close this. Okay, I mistakenly closed the solution without submitting it. So let's submit it first. The same solution, we will submit it again so that it will be marked as the deleted today. Where the okay, we open this. We will submit it. The time complexity of this will be equal to big of n. Okay, because there is only one loop used here, and no sorting any other type of thing has been done. So now what we will do? First, let me close this and this tab. Today the speed of the stream will be a little bit slower because I was stuck in my address. I have told already. Okay. So I think the number of submissions count as the active days. Okay, max tick is 6. Okay, what we will do now? We will try and solve this harder part of majority element, that is majority element second, and we will try to rewrite the code again only after taking a glance of it. So okay, in this case we didn't use the brute force approach that we used in the majority element. We used the better approach that was used in the majority element, but I am not using Moore's algorithm in this case because I don't know how to use it here because I haven't done it yet. So first we will try to do this. After that we will think if we should try it with the Moore's algorithm or not. If we were unable to do this with the own self, we will ask hints from Copilot, and after that, if we will be unable to solve this with Moore's algorithm, we will see the code from Copilot and try to understand it there, and we will do the enough that there also. So let's take a glance. Okay, first sorting has been done in the better approach. Okay, that we used in majority element first. After that, we created an empty vector. Okay, frequency was started from 1 and iteration was started from also first index. Okay, in this case, if check frequency, if num size is equal to num size minus 1, so we initialize the value with 1 because so that it can be compared if nums of I is equals to nums of I minus 1, means if nums of I is equal to nums of I or previous value of that. So in this case, frequency will increase if it's equal to nums of I minus 1. In that case, it will check if frequency is more than n by 3, result dot push back. So we will push back the value of nums I minus 1 in that case, and we will reset the frequency of for new element. And why we use this condition here? Because we have to check it for the last element also, because in the last iteration what will happen, the frequency of that value will not be checked, so we use this, so it checks it for the last time, and if it's true, it will push back the value of that in the result also, because in this case we will have we will have two majority elements. We can have two majority elements. So it is the, you can say it is again checking that if any electron element is present, it will check for it and give and add it to the result vector. So what we will do, we will, okay, and yeah, the time complexity of this will be equal to big of n log n, because sorting has been used here, and yeah, there is only one for loop here that is being used. So we will check for the last element before returning the result. Okay, so let's, okay, what we will do, we will clear this all. Now what we will do, okay, we were using the better approach. So first we will initialize. Okay, first we will create an empty vector. First we will create an empty vector named result. After that we will sort the array in ascending order. Nums dot begin, nums dot end. Okay. So here sorting has been done. Okay, so sorting has been done here. After that we created a, the thing is same. So yeah, we will create an integer n also, because we will use that here also, and after that we will use this variable in the conditions also. Yeah. So okay, I know I am seeing the code again and again, but what I was supposed to do, I was supposed to do the problem on my own again, because it's revisiting. It's not you are seeing the problem for the first time and doing these things. So sorry for that. But yeah, I will try and understand what things are working. Integer n is equal to nums dot size. Okay, so integer n will be equal to the number of elements present in this. So that we will initialize the frequency with 1, and we will write the for loop which starts from the 0th index to the last index. Inside this we will check if what if frequency, 1 minute, I will have to see it again. Okay. This was the condition for majority element first level. This is the second level of it. So this was the condition. Okay, because there is no another variable added. So if nums of I is equal to nums of I minus 1, if this is true, what we will do, we will increase the frequency. Yeah, we will increase the frequency in this case. And in the else case, if it's not equal to nums of I minus 1, what will happen? In that case, it will check if nums of I minus 1 is more than n divided by 3. Oh, sorry, this condition will not look like that. Condition will look like this. Frequency, okay. If condition will also be used, else if frequency, okay, if not will not be used, frequency will be C. Okay, in that case, if will also be used again, okay. So what we will do, we will use that condition if frequency is more than n by 3, we will push back the value. We will push back the value of nums of I minus 1 in the result vector. Okay. After that, what will happen when the loop has been run? We was supposed to, okay, this was the minute. Let me fix the positioning of curly braces because from the past 2-3 streams, I get stuck in the syntax errors because of these curly braces positioning. So, okay, this is done and this is done. After that, what will happen? In the end, it will again check if frequency is more than n by 3 times. Okay, this is true. We will push back num psi minus 1 index value inside this, and after that we will simply return our result. Compile error is happening. What I have done wrong is, let's see. I think there should be another this thing. So it closes the for loop, it closes the function. Okay. Woo! Okay, the semicolons are missing. If okay, else if frequency is more than n by 3, okay, this will push back. Okay, okay, okay. First, it will be here. Okay, this is closed, volume is closed. Okay, we will return the result after the for loop ends. So for loop ends here. We return the result here. Expected expression. Oh, okay. Why it happened again? I think it will be inside this after the for loop. See, there are syntax errors happening. Let's see the code. What was okay? For loop is there, if condition was here, if condition closed here, else condition started here, and else condition closed here, and for loop closed here, that it. Okay, for loop closed here, so what we'll do, we will remove it. After closing the for loop, this thing was happened. Will it work like this? What if we remove it? Okay, let's see. For condition loop, for loop, this start here. If condition closed here, else condition closed here. Else condition did we use? Okay. Inside else we didn't use these curly braces. Okay, we remove that so that code will be little cleaner. Okay. After that, what happened? You are supposed to close the for loop. So the for loop is closed here. After that, else condition. It will check if frequency is more than n by 3. So it will, if it's true, it will return the okay. Push back and return the value. We will try to run it. Num psi minus 1. Okay. Push back. Push back. Undeclared identifier I. Undeclared identifier I. Okay, so this is happening, I think, because the for loop is started here, and if the condition closed here, else condition closed here, then for loop is closed here. So, see, for loop started here, condition started here, closed here, first condition started closed here, for loop closed here. After the we use this if condition, if this is true, it will return result in the end. Then why it's saying identifier is I is not identified by. N minus 1. So how did it work yesterday when we'll push back n minus 1, but why? Maybe let's see. I didn't notice it yesterday. Runtime error. But it will be I then. Here is also 1. I minus 1, I minus 1. Okay, there will here it will be I. Identifier as how man? Here is an you last time check of n nums of n. Let's ask Copilot for it if is there any problem in this code for finding majority element second part of LeetCode problem. Okay. Brother, my code was accepted yesterday after submission on LeetCode. I just want to understand, is the result taught to push back inserting values are correct or not? Because, sorry, just want to know that. We just want to know that. Just want to know that only. Okay. Inside loop, when frequency condition gets satisfied, then we push the last repeated element, that is n minus nums of 5 minus 1. Okay. This is logic correct. After the loop, we push the final streak element in that. This is also correct. And if this condition will not be placed there, it misses the last group. Brother, then why n minus 1 in the first, sorry, I minus 1 in the first and n minus 1 in the second condition. Okay, inside the loop. Okay, I'm using the loop for current element. When I get to know that nums of I not equals to nums of I minus 1, it means the previous group is ended. And what was the group element of that? It is equal to nums of I minus 1. Okay, that's why we push back nums of 5, because it was the last repeated element whose frequency has been calculated. If we push nums of 5, okay, if we push nums of 5, then it will be wrong, because nums of 5 is already a new element that is just started now. Then why n minus 1 after the loop? After the loop ends, last, yeah, after the loop ends, else block not runs for the last group, because comes to an array iteration comes to an end, and for the last group of elements, it the condition will be this nums n minus 1. This tells that it is checking for last element of the array. That's why in the final check we use this condition. We in the final condition we use this to push the value of this index. Okay, n minus 1. It was right. Then here it will be n minus 1. 1, 2, 3. Okay, check this correct. Okay, here's the catch. I will be equal to 1 man. And where the condition gone where frequency. Okay, we have to reset the frequency also after pushing every element. After pushing the element that first comes in the majority. Yeah. So every this case is accepted now. So the what was the problem happening was we used I is equal to 0, but we you, because of that it was unable to check for this condition, and reinitialize we will reinitialize the frequency with the 1 again, so that whenever it push back the current value of nums of phi after checking if its frequency is more than n by 3 in the result array, we will reset that. So start checking the frequency start checking the frequency for the next elements, so that we will get the right frequency. Okay, so how the code is working, let me give a dry run. 1 minute. 1 minute. Okay, the stream is running. Your mic is working. I don't know how the voice will be. So how the code is working, let me tell you. First we created an variables, so it can be used in the conditions to check if it's more than n by 3, and also in this loop. Okay, after that we created an empty result array, so that the majority elements can get stored inside that. After that we sorted the array from end to the begin, so it can be easier to check if if it's equal to nums of I minus 1. So if the value will be equal to nums of I minus 1, frequency will increase in that case. And if it will not be equal to the to in the next iteration, if it will not be equal to nums of I minus 1, then it will check in the else case if frequency is number 3. If this will be right, then it will push back the current value of nums of I minus 1, and frequency will be reinitialized with 1. Okay, so let me use the braces here, curly braces here, and okay, return again. Okay, it doesn't affect the things. So okay, majority element second, we will add our own test case here. In that case, it will turn two majority elements. So 3 comma 2 comma 3 comma 4 comma 4. Okay, the fourth test case is also accepted. In that case, we got two majority elements because 3 and 4 are was in majority in this case when it is divided by n by 3 times. Okay, so we did a dry run, and when the last element will be left, like in this case, suppose this was the thing, we sorted this array. Like, let me give you a dry run example here in a quick. Okay, first we will write here today's lecture number, sorry, today's tree number. day hashtag 9. Okay, something let's use white color for it. DSA journey day 9. Okay, now what we will do, we'll simply make it bigger, not bigger. So DSA journey day 9. Day 9. Okay. Now what we'll do, we'll use pencil and simply, okay, so that in that array, first the array was not sorted. It was a background. So first the array was like this, 3 comma 2 comma 3. Okay, first what we will do, first we will sort the array. First we will first we will sort the array. After sorting, it will be like this, 2 comma 3 comma 3. Okay. So how the code will run, like the C, we will close this and bring it here. First let me submit it again, submit it so that I don't forget submit like I did in the previous problem. Wrong answer. Okay. It gives 3. Why this failed at the submission time? It did work yesterday. Okay. Okay, I have done this. I have reset the frequency at the wrong place. Okay, okay. So after this thing ends, we have to initialize this. If it's passing, all that is cases. Did this gets passed again? So frequency was to be initialized after, yeah, after the group ends, yeah. Because when it will done, then the frequency will reset to 1. When code switches from 1 to 2, frequency not resets, because frequency is not, because it told the frequency is not more than by 3. So the code for not further works. Okay. Our spec placement was right. Just we was supposed to write the frequency, reinitialize the frequency after the if condition. Okay, now we'll understand how this thing is working. So in the starting, let me write it here. Frequency frequency was 1 in the starting, and what? There was no value in the result. Okay. So in the first iteration, the first iteration I was equal to 1 means I was on this index, first index, that is 2. So it checked if nums of I is equal to nums of I minus 1. So in this case, it was not equals to nums of I minus 1. Sorry, here. So it was not equals to nums of I minus 1. So it check if it is more than n by 3, but it was not n by 3. So we reinitialize the frequency with 1. After that, okay. Then in the next iteration, it came here. The I came to I became the index value of I became 2, and what happened? It again check if this is more than this is equal to nums of I minus 1. Okay. So in this case, 3 was equal to 3. Okay. So what happened in this? The frequency was increased from 1 to 2, and it became, sorry, it became 2 after that. After that, what happened? After that, the loop ended, and we checked if this was more than n by 3. So in this case, it was more than n by 3. If we check the number of if we divide this by 3, n by 3, the total values are 3. If we divide it by 3, let's see if it is n by 3, then is equal to 3 divided by 3 will be equal to 1. Okay. So the frequency of this was 2. So 2 is more than 1 in this case. So what we will do now, we will simply close this block. Okay. Like this. So this was how the code is working. Now what we will do, we will okay. So we have revisited 2 problems till now. Let me see what was okay. Now I will try. I will ask the Copilot if can I do it with the Moore's algorithm. Give me the code. Okay. Key idea majority will second. In this we there can be max 2 elements. We can use the extension of most extension of Moore algorithm, and we can track 2 candidates at the same time. Okay. And we can maintain the counts also. In the first pass potential candidate, we take the potential candidates. In the second pass, we verify if its frequency is more than 3 n by 3. Okay. Time capacity of this will be big of n. Okay. So I think there will be, brother, give me hint. what what changes I will have to make in the modes algorithm code that I used earlier in the majority element level first, sorry, part one. This uh, this is part two. Okay, okay, I can adapt that for part two also. Just we need to make some extra changes. So the changes needed is 1 minute. Okay. So now what we will do, we have to track two candidates instead of one. In the part one, we we calculate in the part one we used to one candidate and count one count. Okay. In part two, there can be max two element that come more than n by three times. Okay. For that we will have to create candidate one and candidate two, and for that we will have to okay, count one, count two. Then we will traverse the array. If this is to then count plus plus, and if this to count two plus plus, if count to one is equal to zero, then candidate will be one is equal to num. Count one is equal to one. As to no else, both counts should be increased. Okay, so what we'll do? First, we will copy that code inside that this, so it will save our time. Okay, what we will do? We will paste it in this inside this so that we can use the most optimized code for this also. So okay, now we will ask. Now tell me, brother, and give me the reply in English so that viewers can understand what I am doing. The code is the classic one. Okay, but let's make it down. For part 2, this code won't work directly because now there can be up to two majority elements appearing more than n by three times. You need to track two candidates and two counters and two counters instead of one. Okay. After the first pass, you must verify both candidates by counting their actual frequency. Since not every candidate will necessarily qualify, so in short, if the current code is perfect for part 1, for part 2, we will have to extend it to handle. Give me things where I should make changes. Need and moving from major trend part 1 to part 2. Okay, two candidates in part 1, you only track answer in part 2. You must track candidate 1, candidate 2. So count is equal to frequency and answer name is changed to candidate 1, candidate 2. Okay, so what we will do? End candidate 1 equal to 0, comma candidate 2 is also 0, that count 1, I think it will also be 0, count 2 1 will be 0, and count 2 will also be equal to 0. Okay, we done that. Then the for loop will be like this. Update of file rating. If the current number equal to 101, increment increment count 1. Else if it equals to 182, increment count 2. Are only potential. You must run a second pass to count their actual frequency in the array. Only push the holy moly. If it is else 6, let's see this. If it's equals, okay, country where we are initializing all the variables with 0, right? Okay, okay. This is a starting point. The actual values don't matter initially because the algorithm will replace them as soon as count drops to 0. Then the first part, yeah, pass. Why initialize to 0? In part 1 you set frequency. Okay, that worked because the first element immediately replace the candidate when frequency is equal to 0. Part 2, same idea, both candidates start as empty slot with count 0. As you iterate, as you iterate the first numbers you encounter will fill those slots. Okay, they are just placeholders. After the first pass, you must do a second pass to count the actual frequency of candidate 1 and candidate 2. Only then you decide if they appear more than and by 3 times. Okay, I'm not understanding this. Further, give me. Okay, first we'll try. If it's not work, we will ask the code for this. So what we will do? We will remove the whole thing for loop ends here. What it's saying, what we have to do, if current number is equal to candidate 1, if num psi equal to, but how it will not work, man. Let's see. Am I going right or wrong? Sure, right now not okay. I'm missing a semicolon then. Okay, this is a small thing. Comma between candidate 1. Okay, there will be comma. Missing a semi should be okay. Logic not completed. Right now you only started if for major case we will need case for num size equals to num. Okay. So this will be count plus plus. This will be count plus plus in this case. In this case, count will be increased from 0 to 1. Okay. Count 1 will increase in this case because it is for the candidate 1. So count 1 will increase in this case. Okay. So count 1 will increase in this case. And case for num psi. If the count will increase, then after it, if nums of phi is equal to candidate 2, we will. But how? It can be both. Is when count 1 is equal to 0. Assign new candidate. Is when count 1 is equal to 0. Okay. Candidate 1. So if count if count 1 is equal to 0, we will reinitialize count 1 is equal to candidate 1. That if count 2 is equal to 0, it will we were supposed to reinitialize it with the candidate 2. Okay. If else, okay, first is this case when count 1 is equal to 0, assign new candidate 1. Else decrement both counts. If this, then else count to 1 minus minus count 2 minus minus else count 2 minus minus brackets. It will not run, I know. I think I should put it afterwards. But in the starting count is equal to 0, man. Candidate 1. Let's ask it. Okay. But you are assigning the candidate into the counter, which is incorrect. What we should do when count 1 is equal to 0, set candidate 1 is equal to, okay, and count 1 equal to 1. Click 0. What we will do? candidate, we have to set candidate is equals to current value of num I, and count is equal to 1. Let's think like this now. Yeah, count 1 will be equal to 1. We will initialize count 1 is equal to 1 and put the current value of num's index into candidate. Okay. Same thing will happen here also. Candidate count to candidate 2. Okay. Candidate to 1. After that, what is saying? Saying, but we are saying okay. Again, wrong. It should be candidate 2 is equal to next type. Count 2 is equals to 1. Okay. Decrement case. If the current number does not match either candidate, both counts are non-zero, you need to decrement both count. Okay. In the current number, if the current number does not match either candidate and both counts are non-zero, you need to decrement both counts. Verification step missing. After the loop, you must count how many times candidate 1 and candidate 2 actually appear in the array and only return those that occur for them. Okay, hence if I condoms of I is equals to what else? Splitting a little bit. The code is looking like a mess now, right now. Hello. Okay, mic is working. Issues in current code reset logic where. Okay, because this we are immediately decreasing count 1 immediately after setting it. The decrement should only happen when the current number does not match either candidate. Does not match either candidate. Same mistake for this order of checks. First check if num psi match candidate 1 on 2. Pseudo logic, not full code. If num psi is equal to candidate count plus else if num psi is equals to count plus else if count 1 is equal to 0, candidate 1 is equal to num psi. Brother, I am unable to understand it. Give me the code now. Okay. First pass, find potential candidates. Okay, this loop will traverse the whole array. If else, if else, if else, if else. Okay, this code will be this much bigger. Further give me with the code with the detail. Okay. First, this is this if nums of I is equals to num candidate 1. If num is equals to, but where is num? Okay. Value of num's index equals to candidate 1, count will increase. Okay. Code with the proper comments and give me the try run also so that I can explain it to my viewers. First, if nums of I, if nums index value is equals to nums and candidate 1 will be count will increase, else if nums equals to candidate 2, count 2 will increase, else if count 1 is equals to 0, candidate 1 will be equal to 1. Okay. So first it will, I think it will end for this because candidate first it will initialize the candidate with the current value of num psi and count will be equal to 1 and it will end after that when it will again run. This condition will be true and count 1 will increase. Okay. So that it will again check if candidate 1 is equals to nums index. So it will be equal to nums index, so count will increase. And therefore second pass, if count 1 is equal to count 2 is equal to 0. Let's see the try run example. Array is this. Length is equals to 6, so threshold is 2. Start candidate 1 is equal to candidate 2. 3 2 3 2 2 1. Okay. Count 1 is equal to 0. Candidate 1 is equal to 3. Count 1 is equal to 1. Oh, it's feeling heavy right now. I am unable to understand this code right now. So candidate 1 is equal to 0. Candidate count is 0 in the first. Okay. Candidate 1 will be equal to 3. Count 1 will be equal to 1. That count 2 is equal to count 2 is 2. Count 2 is equal to 1. 3 matches candidate 1. Count 1 will be 2. Okay. 3 matches count 1. And if 3 matches count 2, it will the count 2 will increase. And if but in this case 3 matches count 1, so count will increase from 1 to 2. Okay. And 2 matches count candidate 2, so candidate 2 will become 2. After that 2 again matches as candidate 2 and it will increment, it will do increment in the count 2 again, and 1 is different from both. Count 1 minus minus to 1 and count 2 will be minus minus to 2. Second pass verifies current occurrences. The candidate 1 is equals to 3 appeared 2 times, yeah, and candidate 2 appears 3 times. count 1 minus minus count 2 minus minus. And now pass candidate 1 is equal to 3, candidate 2 is equal to 2. Okay. Candidate 1 is equals to 2. Okay. Final result will be 2. 3 appears 2 times, 2 appears 3 times. So greater than 2, so included. Not strictly greater, so excluded. In this case, 3, 2, 2, 2. Okay, 2 will be the result because 2 has occurred majorly. So I think this thing is happening. So count 1 will be 0, count 2 is equal to 0. Or in teaser if num is equal to candidate 1, count plus what's these all code. I know it is simple, but mind is not working right now. Can you make it more simple and explain it to me more in a more easy way? So yeah, today's stream is not going so well. Imagine you're allowed to keep two boxes only. Each box can hold one number and counter of how many times it appears. As you walk through the array, if the number matches what's in box 1, increase box 1 counter. Else if matches box 2 is counter. Else if box 1 is empty, put the number in box 1, set counter is equal to 1. Else box 2 is empty, put the number in box 2, set the counter to 1 of that. Else both counters go down because this number is against both boxes. At the end of okay, but they are all the at the end of the walk, the two boxes contain possible winners, but they are only candidates. So you must check again how many times they really appear in the array. Only keep them if they appear more than n by 3, okay? An example is given here, threshold will be 2. So majority element will be more than 2. Start box, okay, C. 3 box 1 will be initialized with 3. Count will be initialized with 1. Candidate 1. If nums is equal to candidate 1, but this is not true. First, I think this condition will have to run. So when it will have to run, candidate will be equal to nums, current value of nums, and count will be equal to 1. C2, box 2. Okay. One minute, 1 minute, 1 minute, 1 minute. Okay. So when T appeared for the first time, it was marked as the first candidate. Okay. And when in the next iteration it came to 2, I came to the first index that was 2. So it was pushed in the box 2. candidate it was because candidate 2 value was initialized with 2 and count 2 became 1. So when it when same values occur, count increases and this and this. After that, when it says a different value, different from both, it increases, it decreases the count of both of 1. Okay, count 1 will be 1, count 2 will be 2. Okay, and the box 1 is equal to 3, box 2 is equal to 2. Check frequencies. 3 appeared 2 times, not more than 2, so skip 2 appears 3 times, so 2. So keep. Okay. Result 2. How testing results? We only need 2 boxes because at the okay, if I see it here. So in the starting, the in the first iteration, it will run for the second if else if condition, right? Where where count 1 is equal to 0. Exactly, yeah. Okay, okay, okay. Okay, we'll try to do it little. Okay, now what we will do, we will first we check if okay, we will use the for each loop here. We can use it for int num. Okay, it will run or will traverse the whole array. If what if okay, we use this first because so whenever the iteration in the next iteration the count will increase. So the count can increase. So first this condition will be executed and candidate 1 will be equal to num and count will be initialized with 1. When it will run again in the again, what will happen if num's value is equal to candidate 1, it will be it will increment and if it's equal to nums dot 2 it will make increment in the count second count in the second count second variable. Okay, but when it will happen, when this case will happen, when when this will be executed. When the different value comes, it will be stored in the count2 variable, and count2 will be equal to that num's index, and count2 will be equal to 1. Okay, and after that we use else. If current num is different from both candidates, it will make decrement in both the candidates in both the in the both frequencies. So what we will do, first it says if, okay, yeah, first it says you check if num is equal to candidate 1. If this is true, we have to increase the count to 1 by 1. Okay, so that if num value is equal to candidate 2, we will increase the count to by 1. If, okay, else if, 1 minute, let me check the whole condition will come inside this. Okay, this will be a nested conditions. Do not close it here. Okay, we can close it here. Okay, okay, yeah. Because else case will be outside of that, obviously. Else if what if count to 1 is equal to 0, what will happen? If count 1 is equals to 0, we will initialize candidate to 1 equals to current value of num. Like that, right? Yeah. And else if else if count 2 is equal to 0. 1 minute, I forget to what was to be written here. Okay, we were supposed to initialize the count with 1. Count 1 with 1, and said that candidate 2 is equals to current value of that num index, and count will be equal to 1. Count 2 will be equal to 1. Okay, and if the num's value is not if num's value if num's iteration value, the means the if the value of num is not equals to both of the count candidates, then what will happen? It will decrease count to 1 by 1. Okay, and count 1 minus minus comma count 2 minus minus. Okay, after that what is happening? Okay, like this. Okay, now the code is looking a little cleaner. So what is happening after that? When the for loop has ended, let's bring it here. What is happening after for loop ends? We will do second pass to verify actual counts. Okay. Count 1 is equals to 0. Count 2 is equal to 0. We reinitialize these values. Okay. Now what? 1 minute. Second pass to verify. Okay. We just change the values to 0. For that we checked it using for loop. What we check? We check if nums is equals to candidate 1 count plus plus. That's it. Nums is equals to candidate 2 count 2 plus plus. Let's ask why we use a second check and why we reinitialize count is equal to 0. Part 2 there can be majority elements. The first check count 1 is equal to fills the first box candidate 1. Okay, second box. Without the second check, you would only ever track one candidate like part 1. That's why we need both. Think of it like first string element number, okay, second goes into box 2. After that, we balance counts between them. Why we reinitialize before verification? In the first pass, counts are only used for voting process to decide which candidates survive. Those counts don't represent the real frequency of the numbers. That's why after the loop, we set both counts to 0 and do a second pass through the array to count the actual occurrences of candidate 1 and 2. Only then we can check if they appear more than n by 3 times. First pass is equal to election campaign and candidates fight counters, and second pass final vote counting, and we reset counters and count properly to see who really won. Okay. No, tell me like what happened after the first for each loop outside it. Okay. The first for loop is only about finding potential candidates using voting logic. At the end, you don't yet know the true majority elements. You only have two possible candidates stored, candidate 1 and candidate 2. The count 1 and count 2 are just temporary voting balances, not the real frequencies. Think of it like the first loop is an election campaign, candidates right, okay, and two strongest candidates survive. Yeah. First we filtered those, and those values which came more, those were stored in count 1 and count 2. Okay. And extra values were removed from the array. Sorry, were removed from the count 1 and count 2. Was not again that. Why we reset counter to 0 after that? Because the counter from the first loop are not the actual number of times those candidate appear. Yeah, because when we did the dry run here, the count was 1 and 2. But see, count 1 was, where is count 1? Count 1 was 2 when 3 appeared 2 times, but at the end count 1 became 1 and count 2 became 2. So this was not the real frequencies that how many times they have appeared. So that's why because the count for the first loop are not that actual times, number of times those candidates appear. Okay, they only show how strong they were doing during the okay. So we reset both counts to zero, then run a second loop to count properly how many times candidate one and candidate two appear in the array. If we see this, what is happening here? It traverses the whole array and checks if num size equals to candidate one count plus plus num size equal to candidate one. And candidate one in this case was two. Okay, assume it was two. And if candidate two, if num was not equal to num is not equal to candidate one, then it will increase the count of the second variable, that is count two. And for when candidate two is equal to num, okay. If this will both will not be, and it will seek the values other than that. And correct result, we correct results here, vector integer result. Okay. Int n is equal to num sort size. Integer n. Okay. If count is more than count one. Okay. We used for each loop and name it. Sorry, not nums, only num. Which traverse the word nums array, and inside it we check if nums is equals to candidate one. We were checking this in the first for loop also, for each loop, but that was for only checking the guest candidates. Okay, if this is true, what I have to do? We was supposed to increase count to one, and in the else case, okay, should we write the condition or not? Okay, we can write the condition, but that's not man. That is mandatory. Let's see if it works even with count. No, have to use that because if if any other value like in that errand we saw that one came, so if one will come, it will be added in the count. So we before adding that wrong value, we will use that condition here. If nums, sorry, if num is equal to candidate two, then count to two will increase. Okay, after this for loop ended, what we will do? We will simply create a vector, name the result, and okay, what we will do? We will push back those values. Okay, why it was used? Let me see. It was used because so we can check if the count one is more than number three. Okay, yeah. If count one is equals to if count one is more than n by three, result to push back what if back in the inside this candidate one. Yeah, candidate one, because we want the value of that, not the time of occurrences that occurred. In this case output was 3, we want the value of that, not the occurrence times of occurrences that occurred. So we will close this if loop. Okay, we have already closed this setting. So it will be like this. If count 2 is more than n by 3, we will push back candidate 2 in that. Okay, after that we will return the result. We will return the result in the okay, let's and so else closed and for loop closed here. So let's make it check it. Okay, we use close, open close to closed. Okay, for loop closed. After that we use this initialized count 1 0, count 2. Okay, use this loop. If condition else condition closed. After we close that for loop, after that we created an empty vector named result. After that you make created a variable integer n. If count 1 is more than n by 3, push back to candidate 1. If okay, we can simply remove the braces so that it will look more cleaner. What happened to my keyboard? Mouse. Okay, it's working now. After that, we will return the result. Oh shit, we forgot to remove this. Compiler. Else if comes to else if. Yeah, okay. Line 13 and line 39. Expected this. Okay. Bracket. Anything else? Num2 candidate. Okay, okay, okay. Boom, 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 boom. Error, error. What type of error it's giving? Okay, okay. Region space. Can two. Okay, okay, okay. Cans. Mm-hmm. Okay, this is correct. L, count 1 minus minus, count 2 minus minus. To closed. Count this. Okay. For equal to count this plus s numbers correspond to count 2 plus plus factor int result in numbers count 1 and 3 respect and factor return result and okay. What is saying here, man? After expression, what type of expression? I have already used it. What's wrong now? It says expected. Okay, let's see why when it's mostly syntax mistakes and one small logic slip. Let me point out that then clearly wrong is syntax. This is invalid C++ syntax. It should be else if okay. Okay, I was thinking about that. It was running my mind before that when you use else, it becomes the else case. Okay, count to plus plus. Semicolon is missing where? It's missing. It's missing here. Okay. Return time mismatch. Vector int, not int. But I wrote that, man. Function header. Okay, let's see. It's saying vector int and nums. It's already return result. Oh, way down we go. Way down we go. Let's do this. Down to the earth. Way down we go. There are two small issues related to mismatch. must be vector int majority element. Okay. Here is the mistake. Oh, way down we go. I think it will work now because when I wrote the code, when I erased the code, I think this was also erased when we were writing the code somewhere. Okay, now the code is accepted. So let's submit it first. My brain is right now a little cooked after not understanding these things. Okay, so line beats 100%. I think the time complexity of this will be equal to for loop. We only used a single for loop here. After that, big of anything. The time complexity is equal to big of n, right? Yes, brother. Okay. Hmm. There was one doubt that what if like okay, what we will do? We'll add two here and one here. Then what? Like three will be candidate one, comma. Okay, I think I'm understanding when one will become candidate two, and after when both the after when after then if two doesn't matches the candidate one and two, both frequency will decrease, and when it both frequency will decrease, what will happen then? Count will become zero, and when count will become zero, it will reinitialize the frequency. Sorry, it will reinitialize candidate one with just the current value of nums, that is two, and count will increase again. But I think it will decrease. It will increase when in the next iteration. Let's see. Like three will be candidate one, candidate two will be one. So this will work like this, right? Like in the next iteration, it will not match. It will not match the value. The value will, sorry, in the next iteration, the value will be mismatched with candidate 1 and candidate 2, and count of both will decrease after that when I will be on after that when when I will be on fifth index. Now it will reinitialize count candidate 2 with the current value of num, and count will be equal and count of 2 will be equal to 2 then, right? Okay. Matches? Yeah, matches. Nums2 doesn't match 1 or 2. Both counts will be nums2 count is 2. So candidate 2 will be initialized with 2 and count 1 is 2. Num2 again 2. End of test, candidate 1 will be equal to 3. Candidate 2 will be equal to C. This is an S case. Second pass will verify counts, reset counts 1 and 2 to 0. Count actual occurrences. Okay. So we'll check if candidate 1 is equals to 3. We will check if what if candidate 2, where is that gone? Yeah. Here if num is equals to candidate 1, then count will also, if candidate 2 count will again increase. What has been stored in the candidates? Why we use this? Because so that the filtered value after checking the whole array, the most strong candidates can be stored inside candidate 1 and 2. After that, we reinitialize the count with this and traverse the whole array again and check if num is equals to candidate 1 or 2. Means if num is equals to 3 or 2, so count will increase one by one and at the end. So what will happen? Why we use this? So that it can count the actual number of occurrences. Like in candidate 1, when it will traverse the whole array again, what will happen? It will count when it will be equal to candidate 1, 3 will get added into that again. If it's not, then it will run for 1, and 1 is not equal to candidate 1 and even candidate 2. So 1 will not be counted inside that. After that, it will be run for 3. It will come inside candidate 1. After that, it will run for 2 till the last element, and all the 2's will increase the count 2 for candidate 2. Okay. After that, we will create an empty vector. Inside this, we initialize an integer n is equals to nums dot size, so that we can compare if count 1 or count 2 is more than number of elements divided by 3. If those both will be correct, both the candidate value will be pushed inside that, and we will return the result because we want the values that have occurred. Like if we used our test case that we created there, it will run. Let's create another test case where what 3232 okay, it will what it will give. Let me think what the test case I can change in this. 323221. Okay, what we can do here is we can add another 3 and we'll run for this. It will be accepted also. I knew it. Okay. In this case, it will be 2 and 3. 3 and 2. Expected was 23. But it will pass because order doesn't matter in this case. Woo. Okay. I was thinking that it will not be accepted game because of the expected case, because LeetCode behaves so weird at many times. So now the problem is solved and I've explained all these things. I will try to understand it after the stream also, because this is a wrong code and it's wanted to understand. Okay, we have saved it, also submitted it. What we will do now is let me see. What we can do now is we will now try a new problem, that is pivot index. I picked it from ChatGPT to solve that. It is based on arrays. Before starting that new problem, uh, today it was not planned to solve this with Morse code. It was just planned that I will revisit it and try to write the old code again. But after that, there it was in my mind that I should try Morse algorithm on this. So I tried it and we solved it like this with the help of Copilot. Where the let's close this and this and this. Okay, and this also. Okay, there are 3 viewers. 3 people viewed my stream. Okay, leave it. Now we'll go to this problem. Find pivot index. Okay, it was the name of it was this. Woo! So let me check if my voice is okay. Voice meter is high. Okay. Who's gonna carry the boots and the logs? Who's gonna carry the boots and the logs? Who's gonna carry the boots and the logs? Now let's come back to the problem that we will solve today. The new problem, that is find pivot index. Given an array of integer nums, okay, calculate the pivot index of this array. The pivot index is the index where the sum of all numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the index right. Okay, means in this case output is 3. Pivot index is the index that I think that tells if the rightmost elements and the leftmost elements add up to a same value, the sum of them is same, then we will return the middle value. Like in this case, we return the rightmost value, I think. Rightmost last value. Sorry, leftmost last value. Let's ask this from Copilot. Okay, the first code. Brother, am doing I am doing a new problem now, that is find pivot index. I am stuck at the very start. 1 minute, let me see what we can do. Say we okay, array mid level prefix sum. Create an array sum left where sum left I is the sum of all the numbers to the left of the index. Okay. For each index I, check if sum left equals sum right. If so, return I. If not such I is found, return -1. Okay, it says create an array left. Let's see. Where the sum of all elements to the left equals to the sum of right. 3 values 1, 7, 3, 6, 5, 6. 1, 7, 3 is equals to 11. 6, 5 is equals to also 11. 6 will be at index 3, value is equals to 6. Left is equals to okay. Find the total sum of array. Keep running left sum while iterating. At each index, right is equals to total sum minus left sum minus 1 minute. Don't give me the code right now. Just give me hint, brother. I think I can solve this on my own. Okay. If you see the code, okay, time complexity, okay, we traverse the whole array. Mm, okay, we will see the code, understand it first. Okay, right sum will be equal to total sum minus left sum minus index value of the current nums. Okay, first we will finish it. After that, I will continue my reading. Update left sum. Okay, okay. We will take the hint. Maintain a running left sum. Start left sum with 0. First, we will run a for loop here. Okay. For integer I will start from the 0th index. I will be less than nums dot size and I plus plus. What is says after that? There is the start left sum is equals to. So we will initialize left sum is equals to 0. Integer left sum is equals to 0. Well, what it says, as you move through the array, keep adding the current element to the left sum. Okay, it says as you move through the array, keep adding the current element. Okay, left sum will be equal to what I left sum plus equals to I. Okay, each index the right sum is equals to total sum minus left sum minus I. Right sum, okay. Right sum means this right sum is equals to total sum means total number of sums minus left sum, okay, minus nums I value also. So write sum, it says what it says, sorry, integer write sum is equals to total sum minus left sum minus num I value. Okay, after that, if left sum is equals to right sum, if this is true, what we have to return? We have to return the current index of I. Okay, and in the else case, after the whole for loop will be ended, we will be returning. What will we return? We will return -1 in the else case. Hmm, okay, maintain start left sum as of through at each index right sum is equal to 0. Right sum is equals to some as cases pivot can be at index 0, then left sum is equal to 0. Pivot can be at last index, then right sum is equals to 0. If pivot exists, no pivot exists, then mention try hand. Okay, so the trick is one total sum plus one running left sum. No running for let's do everything states. But we will have to initialize right with what the last index or first. You see my code. But I see a code and I get way stuck. Let me give you clear hints without rewriting the whole solution for you. You wrote left sum plus equal to I. This is wrong. We should add the value. Okay, num. Num psi. Okay, num psi. Because this is not the nums loop. Nums I here also. Okay. Use int right sum. Total sum is not defined. You named that sum earlier. Also, num here is not available. Okay. Correct idea. Int right sum is equal to sum minus left sum. Total sum, okay. Total sum total sum, okay. This is a good convention that we write like this. This is called camel case. We can use this for naming variables. It is a good convention in programming. Let's see if anyone, okay. What we'll do, int write sum. Will it run now? Left, yeah. What it's saying, hint for fix. Keep left sum is equal to 0 initially. Okay. At each index, right sum is equal to. If left sum is equal to right sum, index return I, then update. I, then update. Okay. We'll have to update it afterwards. If, yeah, I write something wrong. The left sum is equal to right sum. So left sum is right sum. Left sum, okay. Left sum is this, left sum, left sum. Right sum is also small. Compiler. Let's see what error has came now. Undeclared identifier left sum. Okay, here again. Line 8, line 10. Okay. Come on, man. Okay. What's the last case? Okay, output is again 0. In this case, output is not giving output. If we put it here, no. Okay, it passes 2. That's this case no. -1. Expected was 3. What the thing is this, man? 0. Output 0. In this case, output is 1. In this case, expected was 3 minus 1. Okay. Let's see why it's failing test cases. The SQL is very test. That's just a small logic mistake in the loop. Hmm. Let's see the code. It's same man. Hmm. At index 0 left sum is 0, okay. Index 0, I have left sum is 0. If pivot is at 0, you must check before adding nums 0. In your loop, you wrote the line left plus equals to num side is after return. Once return the function, oh yeah, you update after the check. But why? But why is it like that? What is this man? How it's accepted? Pivot found, okay. When we already return the value, okay. Let sum plus equals to num side. So it will happen when left sum will be equals to right sum. So in the starting it will not happen because left sum will be 0. And we have done if left where it is gone, okay, right sum is equals to total sum minus left sum minus num num's I value. So how it will run? It says if left sum is equals to right sum, then it will return that pivot index, that is that will be the current index value, which will come at the iteration, after the iteration when left sum is equals to left sum. So it will not be executed immediately. First left sum will be updated again and again, and it will, the condition will check if left sum is equals to right sum. We have already calculated the right sum here. Okay, now understood. When left sum will be equal to right sum, like in this case, see, let me do the dry run for all of you. Okay, let me do the dry run for all of you. See, when first we created an in total sum, inside that we calculate the total sum of the array, of the entire array. In this case, the total sum of this. Okay, the total sum of this was equals to 7, 1, 8, 9, 10, 11, 11, 5, 16, 22 and 28. The whole total sum was equals to 28. Okay, in this case, let's okay, okay, I will. Okay, it was equals to 28. Remember that the total sum will is equals to 28. Okay, we will write it here. 28 equals 28. Okay, left sum is equals to 0. Left sum is equals to 0, and left sum is equals to 0. 1 minute. So we initialize the left sum with 0. Okay. Then we use this for loop, which traverses the whole array. And inside it, what we did, we initialize the right sum with total sum minus left sum minus index of I. So right sum will be equal to, int right sum is equals to total sum means 28 minus 0 minus num's current value of num's index, that is 0 in this case. So when it will run for the first time, for in the first iteration, it will be on the 0th index, and right sum will be equal to 28 minus 0 minus 1. 28 minus 0 minus 1. Right sum will be equal to 1, I think. Let me see. Let's ask it here. Try run. Give try run. Okay, start iteration by iteration. Right sum is equals to 28 minus 0 minus 1. Yeah, it will be equals to 27 in this case. So okay, then it will be on the 0th index. I will be on the 0th index. Right sum will be equals to total sum, that is 28 minus 28 28 minus 0 minus 1. Okay, so it will be equals to 27 in the starting. It after it will check if left sum is equals to right sum. In this case, left sum is not equals to right sum because right sum is equals to 27 and left sum is equals to 0 right now. So it will not return the pivot index. After that, we add num psi index value in left sum. So left sum will be equal to, in the next, left sum will increase from 0 to 1. Okay, from 0 to 1, from 0 to 1. After that, what will happen? I will come on the second index, sorry, first index, that is 7, and Inside this, it will again calculate right sum, and right sum will be equals to total sum minus left sum minus nums of current value of nums I. So in this case, right sum was equals to 27. After that, we subtracted 7, the current index value, and nums I value that was equals to total 8, and it will be equals to 19. Oh yeah, it will be equal to 19 after that, and it will again check if left sum is equals to right sum. In that case, 1 is not equals to 19, so it will again increase the left sum. Okay, it will again increase the left sum value, and left sum will now become 8. After that, what will happen in the next iteration? I will be on the second index, that is 3, and right will it will recalculate a right sum. So in this case, right sum will be equals to right sum will be equal to 1 minute. In this, when I will be on the second index, that is 3. Okay, then right sum will be calculated again. So it will be equals to 9. Total sum is equals 28 minus left sum is equals to 8 minus num psi index. So that will be equals to 8 minus, that will be equals to 8 we have already done. I think I'm doing something wrong here. The dry run, okay. First left sum, this left sum is came to, we have calculated left sum till this, and it subtracted from this. So 19 is left now in the right sum. So after that 90 is left, we again run that loop, and current value of num psi, that was that was this that was this got stored in the left sum. Okay, I forgot where I was. Let me. um, Okay, we can do. We can check it here. Okay. Now I will explain it to you too clearly and quickly. I is equals to 0 when I will be on the 0 index, that is nums, that is 1. Right sum is equals to 27 will be to equal to 27. Left sum is 0. Compare 0 is not equals to 27. Update left sum because 0 is 1. After that, this again it will minus 28. When I will be on first index, it will right sum will be recalculated, and right sum will be 28 minus 1 minus 17, it will be equal to 20. Okay, we have done it wrong here. So what we will do, when I will be 0, nums left sum will be 0. Update left sum is equals to 0 plus 1. Okay. Again after that we play plus 7 here, and here what happened, here we 28 minus 0 minus 1. After that, what we done, we subtracted 7, that from inside this. Okay, the now what happened, okay, we came to here, then right sum will be equals to 20. it is every time subtracting from total sum, okay, then calculating right sum. So when I will one, okay, we get that and come near to this. Okay, compare one is not equals to this. Then we will update the right sum. Sorry, left sum will equal to 8 plus 3. 8 plus 3. In this case, the left sum will be equal to this, and we will again subtract. What we will subtract 3 from this also, and it will come. See, 11 minus 6. Okay, 7, 8, 9, 10, 11. 28 minus 11 is equals to 18, 17. So, okay. Oof. Let me finish it here. When I will use 0 index nums will use this, and right sum will be equals to this, left sum will be equal to 0. Compare, we will compare 0 with 27, it will not will be equal to left, will not be equal to right. After that, we update the left sum from 0 to 1. We will add the first index value in the left sum. After that, I will be on the second iteration, and I will be on nums first index value will be equals to 7, and right sum will be equals to 28 minus 8, and it will be equals to 20. Left sum is equals to 1. When we compare it, 1 is not equals to 20. Update left sum, we will do the left sum afterwards, and left sum will be equals to 8. After then, I will be equals will come on the second index, that is 3, and then right sum will subtract 8 minus 3 is equals to 17. Okay, and it will again compare if it is equals to 17 but is not, then we will update the left sum again. After that, when I will be on the third index, that is 6, right sum will be equals to 28 minus 11 minus 6 is equals will be equals to 11, and left sum is also 11 in this case, so we will compare 11 versus 11 equals, and we will return the pivot index, that is 3 in this case. Pivot index 3 means 1, 2, 3, 4. This value will be the pivot index in this case. 3, 3, 3. If we create our own test case here, what we can do is 1, 7. If we add 3 here, comma 3 here, okay. So 3, 7, 8, 9, 11, 13, it will be equal to 14 this side, and this side will also be equal to 14. So it will should work. If we create another, like add 4 in the last and 4 in the starting, it will work. So here it will give 14, and here it will give 17. Sorry, here it will give 1, 2, 3, 4, 5th index, 5. Sorry, the fourth index. Here it will give third index. Or let's see what it will give. Here it gives the fourth index. Okay, 0, 1, 2, 3, 4. Okay, yeah. It adds up to 14, and it adds up to 14 here. And in case 5, it adds up to 18, and it adds up to 18 here for 0, 1, 2, 3, 4, 5th index. Okay, in this case, we will submit this solution. Okay, it beats 100%, and so now we have done this problem. I stressed the dry run so very for long. Sorry for that. but we did this problem. We saw it from Copilot, but we understood it afterwards. This is wrong. This is wrong. But see, I am noticing that we can use if condition, and after that we can update the values. And if even after that, it will the return this will happen after when it will be equal to both. This is this feels like a magic. Okay, so now we have done this. Now we will check if it time complexity of this will be equals to big of n. It says. Let's see. If we do the analysis of this, big of n, okay. So let's quickly summarize the stream, what we have done through the stream. So first we revisited the majority element problem part 2, and we tried to write the code as much as possible by self, and using the better approach that we used earlier, and submitted it. After that, we did this problem with the most optimized approach, that was Moore's algorithm, which we used in the majority element first part also. So we tried to implement that in this case also, because it works, because it works because we use an extension of that as extension in this case of majority element, finding majority element. And in this case, we chose two candidates and two counts. And then we push back the value, which was more than n by 3. So this was for checking if there are two elements, there can be two elements in this case, or if we are checking majority for it. So the time complexity of the better approach that we used in this case, sorry, in this problem, was equals to big of n log n, because we use sorting in that approach, and in this approach we the time complexity of this was equals to big of n, because we only used for loops, not any nested loops here. We only used if else conditions and single for loops, and the time complexity of it was equals to big of n. After that, what we did, we okay, sorry, I think we revisited this problem also, because it's showing that we revisited it 3 hours ago. 6 submissions on today. Okay, so first we revisited the majority element first problem, if I remember. Okay, we first revisited this problem, and we tried to do it with the Moore's algorithm again, and did it. And the time complexity of this was big of n. After that, we revisited the majority element second problem, and done those things that I have told you already. After that, what we have done, we gone to this new problem and solved it today with the help of Copilot. And it was a good problem. Like here, the code feels like a little magic and hard works. Like and I will say that if in this problem we was supposed to find the pivot index. What is pivot index? Pivot index is the index which comes between the which comes when the rightmost values and leftmost values sum is equals to is uh, is same and it comes between them. Okay, so it becomes the right pivot index. The time complexity of this was equals to big of n because we only used single for loop here and here we use first for these two. After that we use for loop here and after that we are writing this for. Okay, so in total today we first visited this problem and after that we first revisited majority element problem part 1. After that we revisited majority element problem part 2 and first solved it with the better approach that we used in the earlier streams. After that we tried to solve it with the Moore's algorithm that was implemented in the majority element first part also. Okay, so we did it with that also and tried to understand that also, and I gave drawing of that to you, all of you guys. After that, we jumped onto a new problem that was pivot index, find pivot index, and we did with the help of Copilot. I will say that I used Copilot a lot in this stream because there was no plan of doing this stream. I just started stream and gone with the flow. Today I was stuck in some matters and I didn't got time to do the stream. So I quickly opened my laptop and jumped on the stream and did all these things. And sorry for that part where I did the dry run. I was trying to explain the dry run, but it was very messy. It was looking very messy. So sorry for that because it did take a long time and I was unable to. I was forgetting the values. So I explained it with the help of I explained with the visual representation of Copilot. Okay. So this was all for this stream. If you learned something from this stream, please like this stream and subscribe. Make sure to subscribe to the channel and tell me in the comment section that give me the reviews in the comment section that how are you seeing this stream? Are you liking it or not? Or if I'm doing anything wrong, tell me that also so that I can improve that in the upcoming streams or videos. And yeah, so now I think I should end the today's stream, that is day 9 of C++ DSA journey. Okay. So I am ending the stream and we'll eat this afterwards. Is there anything left to say? Let me check if I have added that problem. Okay, we have added that problem in the favorite index, favorite lists. Let's close this all. Okay, let me open this. And yeah, one more thing that we also did the dry run here of that problem. I think it was majority element first part or second part, right? It was majority element second part, yeah, because we did here n by 3. Okay. So I'm in the stream now. So till then, keep learning and keep